Okay, here we go. Synthetic division. We're going to start with really easy quadratics before we start cubics, and then you guys will practice on quadratics so that you can buy in, because you can factor it and verify it yourself. Okay, so we're going to find our roots. Remember, roots are the same as x-intercept, zero, solutions, but normally when you're talking about synthetic division of polynomials, they always ask you to find the roots. So that's the preferred word, okay, but it's really x-intercepts. All right, if the leading coefficient is 1, then we divide by the factors of the constant value. Okay, this will make sense to you as we move forward. Both of this one is a 1, so this leading coefficient is a 1, right? Because remember, it's a standard form, right? My exponents are 2, 1, constant, which is really x to the 0, right? So if this is my degree, my highest degree, and this is my leading term, my leading coefficient is 1. So if my leading coefficient is 1, then I'm going to divide by the factors of the constant value. The 28 would be the constant value. This one will apply here. It gets really messy. That's why I'll start with quadratics. You're going to do this in pre-calculus. So if you move on to pre-cal, Miss Campbell was teaching it like a month and a half ago, so you get this first semester again. Okay, if leading coefficient is not 1, and in this case it's 2, right, because it's a standard form, my exponent is 2, 1, 0, right? This is my constant, this is my leading term. If this is my leading term, my degree is 2, my coefficient is 2, okay? So that's my leading coefficient. All right, so if the leading coefficient is 2, and 2 is not 1, then you find your factors of the constant value, just like we did here, and the factors of the leading coefficient too. Okay, so you're going to end up with 2 lists of values. Your possibilities grow, and I know this is kind of confusing. You'll see it. Okay, and that's because you're going to have the ratio. You're going to have this list, you're going to have this list, and then you're going to have the ratio of the constant list divided by the leading coefficient list. You'll see. But that's where it comes out to. If this is not 1, you potentially have 3 lists. This list, and then the together fractional list, okay? All right, here we go. All right, this is gonna be really easy just because they're quadratics. All right, so like when we did dividing polynomials and we did the long division, this is now synthetic division. So we remove the variables and we just take the coefficients, okay? So first of all, let's find our factors. Okay, my constant is 28. So 28, if I was to do the factor tree, right, it's 1 times 28, right? So that's a factor, okay? And 1 is a factor, right? Okay, 4 and 7, right? So 7 is a factor, 4 is a factor. And then this is 2 and 2, and so 2 is a factor. Okay, so as you do your factor tree, whenever you hit a different number, that's a possibility. Okay, so what is my list then? Let me make sure you guys can see. All right, I have 1, but remember, it can be positive 1 or negative 1. So I have plus or minus 1, and we'll put them in numerical order. 2, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 28, right? You got to know your factor tree, right? This is your factor tree. All right, now I know you guys can write, let me get scratch paper. If you know how to factor, you're like, can I just factor it? Like, this is ridiculous, right? Because you're like, wait, let me see, 2 numbers and multiply to negative 28, but add up to 3. You're like, ooh, 4 and 7. 7's positive, 4 is negative. So I get x minus 4, x plus 7, right? But that's in factored form. So if I ask you to solve, right, the zero product property, right? If you perform the zero product property, you get 4 and negative 7. Okay, so as you can see, I have a positive 4 there and I have a negative 7 there. Okay, but we're going to get rejected first. Like, obviously, I'm going to do one of them to get rejected, and then we'll pick one that works. Okay, so here's what happens is you can factor these because we're going to getting into 3s and 4s, and so factoring like this doesn't work. And so that's where synthetic division comes into play. All right, so you already know what the answer is. You should have that buy-in. So now let's synthetic divide. And I think I'm going to run out of space with what I have here. Okay, so the way you set it up is I'm going to do plus 1 first. Okay, so I choose positive 1 first to synthetic divide, and I'm going to get rejected, and I'll show you what the rejection looks like. Okay, so I'm gonna pick my divisor here, right? So here's my positive 1, and if you want to write the positive, you can. Okay, I'll draw this line here. Oh, it's really dark in here. The light's turned off because I'm here alone. Let's put more light. On the other side of the room. Yeah, okay. So, what am I doing? Oh, so now we're going to take the coefficients of our dividend, which is the polynomial. Okay, that's a 1. That's a positive 3, and you can write positive if you want, and this is a negative 28. Now, we're going to end up filling in these numbers here, and your remainder is going to be right here, right? This should be like your remainder. If you guys look at Google Images, sometimes they put like a little box here, but I don't. I'll never remember it. Okay, so this is my dividend. This is my divisor. This is going to be my quotient. This is going to be the binomial afterwards, okay? And this is my remainder. If this remainder is 0, awesome, you found a factor. If the remainder is not 0, it's a fail. You got to go back to this list and find another value, okay? All right, so here's what you do. You bring the first number down. So this 1 comes down, that leading coefficient. Okay, now you're going to multiply. What is 1 times 1? 1, and you put that there, right? So that goes here. Okay, so now what's 3 plus 1? 4. What's 1 times 4? 4, and so there's my rejection. I get 23. This is not 0, so 1 is not a factor. Positive 1 is not a factor, right? It's not a real factor, a real number, right? We're looking for real. We're not doing imaginary. We're doing real, okay? Fair enough? Okay, so that one's out. All right, so let's do another one to get rejected. Let's do negative 4, because oh no, negative 4 is my bad. Let's do positive 4. I just realized. All right, so we'll get close, and then afterwards we'll do negative 4, which actually is, oh, you can't see. I have to turn the monitor towards me because I can't see what I'm writing. All right, so I bring the leading coefficient down. I multiply, right, my divisor times that 1, so 4 times 1 is 4. 3 plus 4, oh, I am going to get it, whoopsie. All right, well, we're going to get a good one. Okay, 4 times 7 is 28, and so what's negative 28, positive 28, you get 0. That is my remainder. If your remainder is 0, yay, that is a factor. So that means positive 4 is a factor. Yes, okay. All right, so how does that write now? What do you do? I don't have very little space here. I'm trying to figure out where to put it, because now that I know, I'll put this one on another sheet of paper. Okay, so let's kind of take it over here, sorry. 4 is a factor, right? Okay, so then now what do you have here? You have this quotient left over, okay? So what I have is, if this is x squared, this is decreased by a degree. So this is now x to the 1, and so you have, I know you guys see 1 and 7, but it's really 1x plus 7, which is your binomial x plus 7. Okay, when you synthetic divide and you get a 0, this tells you that this is a factor, right? That this is a solution. What you have is x equal 4, but if you kind of go backwards, zero product property, it's actually x negative 4, and so these are your 2. This would be factor form, not that you need it, you don't have to write that. Once you get the 4, that's your factor, that's a root, this is a root. What's your other root? if they give you x plus 7, because that's what it came from here, if you perform the zero product property, x plus 7 is now x is equal to negative 7, and these are your two roots, which when we factored from what we know, right, two numbers and multiply to negative 28, add up to 3, we got factored form. We got 4 and negative 7. There's my 4 and negative 7. So this is a part where students mess up, is that when you get the 4, sometimes because this is x plus 7, you guys will write the x plus 7, and this is good. You guys are good with this. When you get your quotient, you guys know to just lower the degree, right? Because remember, I know you can't see it, but remember, this is originally x squared. When you synthetic divide, just when you, like when you're doing your long division, your quotient is going to be 1 degree lower, less. So if you're x2, my synthetic division quotient is going to be x to the 1, because 1 degree less than 2 is 1. And so that's why I get x plus 7, and that's where that goes. Okay, so now the 4, but it's negative 4. That's because when you synthetic divide and you get the remainder of 0, positive 4 is a root. Positive 4 is a factor. It is a root. So that positive 4 is after the zero product property. That's positive 4. So if you guys backtrack to factored, actually that probably is going to confuse you. I'm writing that. You zero product property, it's negative 4, and that's how you get. You don't have to do this, but I'm just kind of showing you guys. All right. Okay, so now let's try when the a value is not 1. And I'll show you the big long list. And now I realize there's no way it's going to fit here, so I'm going to have to write it on another sheet of paper. And so then I'll give you guys like 2 and 2 of each for you to practice with squares, and then we'll move on to cubic. Okay, so let me just put this here. And I put the 1x there, not just x, just for the case of synthetic division. You guys know to write the 1. Okay, look, so this is going to be a really long video, I guess. Yeah, I'll just keep going. Whatever. You guys can pause it. All right, find the factors of your constant. Okay, remember, this is my constant term. And so if I take the factor tree, can you see it? Yeah. I get 1 times 15. This is a factor. That's a factor, right? 3 and 5. That's a factor. That's a factor. Okay, so when I'm taking my potentials to use for synthetic division, I have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. This is going to be like, you're going to have a really long list, so just bear with it. Okay, so your first list comes from the constant. If the a value is not 1, right, if the leading coefficient is not 1, then you find the factors of the constant value, that's what we did here, the 15, and the leading coefficient, that's the 2. So if I find the leading coefficient of the 2, right, 2 is 1 times 2. So there's my list, plus or minus 1, plus or minus 2, right? Okay, so those are my 2 lists. Okay, but now you have your final list is your possibilities grow by the ratio of the constant values as a ratio, oh, I forgot my 1, ratio over the leading coefficient values. So if I take my constant over, I know it sounds confusing, and it's a really long list. All right, so if I take my constant and I divide by my leading coefficient, your potential roots are, okay, so I'm going to take this list. All right, if I divide by 1, right, 1 divided by 1 is still 1. 3 divided by 1 is still 3. 5 divided by 1 is still 5. Plus or minus 15 divided by 1 is still plus or minus 15, right? Okay, so far my list is still the same here, right? So when I divide by 1, it stays the same. Okay, so that one I checked out. There's my list. Now the 2, though, I'm going to have a fraction, a fraction, and a fraction, and a fraction. So what is 1 plus or minus 1, right? divided by plus or minus 2. Okay, so that adds plus or minus 1 over 2. Okay, so now do the next one. Plus or minus 3 divided by plus or minus 2. So there's plus or minus 3 over 2. Plus or minus 5 over 2. Oh wait, I forgot to write, sorry. And then this one, plus or minus 15, plus or minus 2. And so now I have plus or minus 15 over 2. Okay, what does that tell you? The reason why, so these are the possibilities. So if you guys are doing your synthetic division here, you can get really stuck in doing like 1, 2, or 3 of these before you hit an actual 0 remainder. Remember, this is your goal here, is to get a 0 remainder. If you get the remainder of 0, that number becomes a root, okay? So 2 of these, so your 2 numbers are buried here, just like here with the, right, just like when we factored, we knew we had 4 and -7. If I look at my list of factors, there was the 4, positive 4, there's a -7. So if you guys start at 1 and you constantly just go left to right, sometimes students skip around and you can kind of waste time because you're like, oh my gosh, I keep hitting everything but what I'm supposed to get. Yeah, that's kind of what happens, okay? So they can actually take up a lot of time, these problems, or you can actually just pick a number and then you end up just picking correctly and boom, you get the 0 remainder and you get your roots quickly. So sometimes it's just luck, okay? Okay, so here, if you kind of have an idea then too, you guys, it can kind of help, okay? All right, I have 2, I have 1, and I have 15. All right, so I'm still gonna do the positive 1 just so you guys can kind of see the numbers. But then, all right, for me, I'm gonna pick a 3. Okay, why would I pick a 3? You have 15. In order for you to create 15, you need a 3 and a 5, right? But because this middle B value is a 1, and I have a 2, 3 and 2 make 1, like if I'm subtracting. So I'm kind of thinking I'm gonna go with the +3 and the -3 and see if one of these is it. I have a feeling one of these is gonna be a factor to that, because if you kind of know your numbers, you're gonna go that route. Okay, why don't I think it's 5? 5 and 2 make 10, and then 2 and 5 make 3. Just the numbers don't match. If you guys understand expanding and the process of foiling, you should kind of know your numbers have to come from your factors, right? Just like here, when you have the 28 and the 3, you have to know your numbers have a relationship and where they're placed. So I'm gonna choose here, but let me first get rejected. Okay, let's get rejected. All right, so here we go. I love getting rejected, you guys. All right, so that's what you learn in life. You mess up, but then you learn. Okay, here we go. So I'm gonna take a positive 1, right? All right, so what happens? Bring it down, I get a 2. You're gonna multiply, right? So 1 times 2 is 2. Add 1 plus 2 is 3. 1 times 3 is 3. And so there's my -12, and nope, not it, right? Nope, fail, right? Okay, so let's move on to -1. Let's get, well, let me do, I want to do 15 because the numbers are all big. And we'll just do -1. All right, 2, 1, -15. Bring down the 2, you see? Okay, multiply, oops, not mut. -1 times 2 is -2. What am I doing? -1, subtract 1 minus 2 is -1. -1 times -1, negative, positive, and so you're left with a -14. And again, nope, that's a fail, right? It's not a factor. Okay, so I have a feeling it's either 3 or -3, so let's try that one. All right, so we might get rejected again. Let's do +3 first. 2, 1, -15. Right, so bring it down to, okay, 3 times 2 is 6. 6, 1 is 7. 3 times 7 is 21. That's right. I don't even bother. That's just a fail. Okay, so let's try -3. And you'll get faster with this because then you'll kind of realize sometimes you can kind of do it in your head if the numbers match. Okay, so 2, that's -6. Ah, there we go. -5. What is -3 times -5? +15. Yay, there's my 0. And so this is a root, right? So because I got the 0, this now becomes a root. And so I get x equal -3 is a root, right? So if I was graphing, that would be an x-intercept. Okay, but remember, if they want you guys to find the other roots, you have to kind of put it into factor form. Okay, so if this helps you, you don't have to do it. But if you were to put it as a factor, a binomial, this is x plus 3. Okay, because if it's negative, zero product property, go backwards, it's x plus 3. All right, here we go. Remember, we started off with an x squared. It's a 2. So this is a 1, right? So remember, this is x to the 1, and this is my constant. So my other one is 2x minus 5. And if I zero product property that, just because this one, oh, I had 5, 2x, 5 divided by 2, sorry. And you get x equal 5 halves, positive. And so these are my roots. And notice that 5 halves was on my list. Where is it? It's here. So here and here, it was in the list. So the reason why you build a fraction of your constant over your leading coefficient is because one of your binomial factors is going to have a coefficient that's not going to be 1. And that's where you guys pick up the fractions. So the fraction looks weird to you. It makes sense. Don't ever pick those to synthetic divide. Go by your integers and kind of look at your numbers to see what actually can give you a 2, a 1, and a 15. Okay. All right, I'll type in 2 problems, or not 2. I'll type in a problem of each type, several of them for you guys to do, and then I'm gonna make more videos. Oh, the lights went out again. Okay, perfect time. Yay.